Before dawn, Ukraine launched a coordinated long-range drone operation deep into occupied territory. At 4:20 a.m., 44 UJ-26 Beaver drones took off simultaneously from a concealed launch site near Kharkiv. Their target was a railway bridge in Luhansk, a critical logistics artery linking Russian supply routes between Luhansk and Donetsk. This bridge was not just infrastructure, it was a key lifeline carrying fuel, ammunition, and reinforcements directly to the Eastern Front. The operation had been in preparation for nearly 2 months. Ukrainian planners worked in complete secrecy, carefully mapping Russian radar coverage and identifying gaps in the air defense network. Each drone was programmed to fly at extremely low altitude, hugging terrain features to stay below radar detection. The objective was simple but extremely difficult: reach the target before Russia's layered air defense system could organize an effective response. What made the mission especially risky was the depth of Russian defensive preparations. After repeated Ukrainian strikes on logistics routes, Russia had reinforced the region with a dense air defense network, including Nebo-M surveillance radars, S-350 Vityaz systems, Pantsir S-1 batteries, Tor systems, and electronic warfare units. This was not a single defensive line. It was a multi-layered interception system designed specifically to destroy low-flying drones before they could reach strategic infrastructure. The first layer of that defense was the Nebo-M radar system, responsible for long-range detection. It could identify low-altitude targets at great distances, but it had a critical limitation. It could detect threats, but not precisely guide interceptors alone. It depended on other systems to complete the targeting chain. Ukraine's strategy was built around exploiting that delay, compressing the time between detection and response until the system could no longer coordinate effectively. As the Beaver swarm crossed into contested airspace, the drones dropped even lower, flying just above terrain level. Hills, trees, buildings, and railway structures created constant radar clutter, making tracking far more difficult. Each additional kilometer without precise detection reduced Russia's reaction window further. Soon the drones entered the engagement zone of the S-350 Vityaz system, one of Russia's most advanced medium-range air defenses. On paper, it was more than capable of handling drone swarms. In reality, the system was forced into a constant cycle of losing and reacquiring targets as the Beavers slipped in and out of radar visibility behind terrain. Instead of facing a clean interception scenario, Russian operators were forced into fragmentation, multiple radars, multiple tracking updates, and delayed firing decisions. That delay became critical. By the time the defensive network fully understood the scale and direction of the attack, many of the drones were already inside the final approach corridor. Then environmental conditions made things worse. Thick fog rolled over the area, followed by heavy rain. Visibility dropped sharply, and radar returns became unstable due to ground clutter and weather interference. Small drones flying at low altitude became even harder to distinguish from background noise. Every second spent confirming a target became a disadvantage for the defenders. Despite this, Russian air defenses began engaging. Pantsir S-1 systems activated, launching interceptor missiles and opening fire with rapid-fire cannons. Several drones were destroyed in the final approach, but the defensive system was already operating under severe time compression. The remaining Beavers broke through the outer ring and reached the railway bridge. Explosions struck key structural points: the deck, support pillars, and rail connections. The damage was immediate and significant, disrupting one of Russia's most important logistics routes in the region. The bridge was no longer fully operational, forcing a partial collapse of supply flow into the Eastern Front. But the operation did not end there. Almost immediately, Ukrainian reconnaissance confirmed the movement of a Russian military train carrying fuel, ammunition, and equipment that had already crossed the bridge before its destruction. If it reached the front line, the impact of the strike would be partially reduced. Ukrainian command made a rapid decision. The remaining drones would be retasked in real time. The Beaver swarm shifted focus and began tracking the moving train along the railway line. By this point, Russian forces had fully activated their layered defense network. S-350 systems covered medium-range interception, while Panzer S-1 and Tor units protected close-range zones. At the same time, electronic warfare systems began jamming GPS signals to disrupt navigation. The jamming initially caused some drift in the drone formation, but the Beavers quickly switched to autonomous navigation. Using inertial systems and terrain recognition, they continued tracking the railway line, following physical landmarks such as tracks, power lines, and stations instead of satellite signals. To increase pressure on Russian defenses, the drones split into multiple groups approaching from different directions. This forced Russian operators into constant target switching. Instead of focusing fire on one axis, they had to distribute attention across multiple simultaneous threats, increasing reaction delays across the entire system. As the swarm closed in, the train itself became a more complex problem. It was moving. A moving target significantly reduces strike probability, especially under heavy electronic interference. Ukrainian operators adapted immediately. One group of drones surged ahead of the train and struck the railway track itself. Two Beavers detonated directly on the rails ahead of the convoy, bending the track and destroying the passage line. The train was forced into an emergency stop. Steel wheels screeched against damaged rails as the entire convoy came to a halt, transforming it from a moving target into a stationary one. That single adjustment changed the entire battle dynamic. With the train immobilized, the remaining drones launched their final attack runs. The first strike hit the locomotive directly, destroying critical propulsion and control systems. The train was effectively disabled in place. The second wave targeted fuel cars, triggering massive fires that spread rapidly along the convoy. Thick smoke began rising across the railway line, reducing visibility but also masking further drone approaches. Under this cover, additional Beavers struck ammunition cars deeper in the train. Secondary explosions began to cascade through the convoy. Stored munitions detonated in sequence, tearing apart rail cars and scattering debris across the tracks. Several cars were thrown off alignment, and fire spread rapidly along multiple sections of the train. By the time the attack concluded, the supply convoy was effectively destroyed. The locomotive was disabled, fuel cars were burning uncontrollably, and ammunition explosions continued to ripple through the remaining rail cars. Heavy rain fell over the scene, but it was powerless to extinguish fires fueled by diesel explosives and military cargo. What had been a functioning supply route just minutes earlier had turned into a destroyed logistics corridor, completely blocked and burning. Strategically, the implications went far beyond the physical damage. Ukraine was no longer targeting only frontline units. Instead, it was systematically attacking the logistics architecture that sustained Russian operations. Railway bridges, transport corridors, and ammunition trains were becoming priority targets because they directly influence battlefield sustainability. For Russia, the consequences extend beyond a single strike. Every disruption to rail logistics increases reliance on truck convoys, which are slower, less efficient, and more vulnerable. At the same time, each attack forces Russia to redeploy air defense systems away from the front lines to protect infrastructure deeper in occupied territory, stretching defensive coverage thinner across a wider area. This operation also highlights a broader shift in modern warfare. Even advanced air defense systems can be stressed when faced with coordinated drone swarms using low-altitude flight, autonomous navigation, environmental masking, and multi-axis saturation tactics. The objective is not simply destruction, it is system overload. If you enjoyed this analysis, subscribe now and join our community, and turn on notifications so you never miss our next breakdown.